Welcome to Energy System Modeling course, exercise number 4. So again, the exercise can be found in the Moodle folder, and there's a lot of data in here, so we can go ahead and download the whole folder. So from here, I'm going to extract these all into here. And let's go ahead and open the exercise 4. So at first, we are supposed to gather some data. So what we want to do is we want to build an electricity system model and model the price and the consumption of the production assets. And in here, there is blank model, so this model incomplete. So you can go ahead and open that. And in here, I have predefined which kind of assets we want to utilize. And there's a template on how to build the model. So essentially what we are going to be making in here is that we have a certain capacity of these production assets. So let's put, for example, nuclear on the bottom in here. So that's nuclear. Then we're going to have biomass after that. And then we have hydro. Maybe in the example, it was the other way around, that hydro was first and then biomass. And then we would have, for example, wind in here. So we are trying to determine the prices of these. An arbitrary example, if the price euros per megawatt would be in a way that nuclear was 10, this one was 15, this one was 20, and this one was 25. Notice that the hydropower, of course, is closer to zero, but this is an arbitrary example in here. And our consumption would be up to this level in here. So in the Excel file, what we are trying to determine is to arrange the blocks the way that nuclear comes in here with full capacity like this. Then the biomass, since it's cheaper, comes into here. So biomass, and then wind would come up till here. And of course, wind is something that's not freely dispatchable. So in that sense, this example doesn't make too much sense, but it's just to show you that if our plants were freely controllable, adjustable, so you could decrease the amount of production from here, then the merit order would be nuclear, biomass, wind, and you would downgrade the wind or decrease the wind production to this level. So that's what we're trying to do in Excel with every hour of the year. So first we have to go ahead and download the data. I have already given you pre-existing these downloads, and I've already kind of pre-processed them, but I'm still going to show you how it's going to be done in here. So at first I'm going to go to FinGrid, and we are trying to look for wind power. So let's write wind, and it gives us these data downloads. So total production capacity used in the wind power forecast. And you cannot in here select universal time coordinated. It doesn't even state in here, in my opinion, what is the time zone. So I'm assuming it's going to be the local time. But that doesn't, in this case, actually matter too much, since we are only interested in the approximate capacity in here. So let's go ahead and download the year 2021 and each time period on its own row. So I'm going to download the data and let's see what do we get. So we are going to be using this one uh, for the wind production modeling in a way that we're going to calculate the capacity factor based on these. So as you can see, my Excel doesn't recognize these as values now. So I'm going to go ahead and paint them all. And then from here, I'll convert to number. So that is my wind capacity for that year. And wind capacity in megawatts is going to be, so there's the hydro capacity factor, wind capacity factor, and I'm going to put the wind capacity in here. And there is 8,760 numbers or elements in there. And if I draw a graph out of it, you're going to see that there's going to be some increases during that year. So that's why we have to take that into account. So in 2021, it increased from 2,268 up till over 3,200. So that's where you can get the wind capacity data. So after that, you want to go ahead to this Ensoe transparency platform, and there's a lot of things you need to download from there. So I'm going to go ahead and log in here. Like this. So let's see the list. So day ahead prices for Finland and SE3. So this is the third area, price area in Sweden that's around Stockholm. So transmission, and from here you can see all the data views. I have it in the recently used data views. So I want to get the price for Finland in 2021. Let's select the random date from here and go to this table, and notice that I have the universal time coordinated, and I'm going to go ahead and export the data from here. So day ahead prices for year, CSV, and now we can open it. So from here, you can see we have to process the data. So let's select all of those text to columns. Let's try that again. So text to columns are delimited, and it's going to delimit it with comma and space. So let's see that. And from here, we can see we have the electricity price, and again, 8,760 elements. So I'm going to go ahead and paste this into this Finnish electricity price in here. We don't need to save that. Yes, so then let's go to Sweden. So in here, let's select the SE3 area. Seems that it's taking a while. And to be on the safe side, I'm going to select one day and see that it changes. So it's actually 2021. So again, we're going to go ahead and download the data and open the file over here, so we can data text to columns. Again, for some reason, it's not showing it, but when I click again, then it's okay. And finish. And from here, and this is actually rather similar as the price in Finland in 2021. So if you were to draw these are really pretty much the same. So it just means that this Swedish zone is actually the strongest influencing factor in these electricity prices in Finland at that year. So what else do we need? We need installed capacity per production type. So that is what we can download from here as well. So there's the generation. and actual generation per production type, installed capacity per production type. So we're going to go ahead and select this one. And let's close the day ahead prices from here to save. And again, let's go to Finland, and we are going to take it from year 2021 till this year. So we only need that 1 year. And I can export the data again in CSV. So that's the installed capacity. Now you don't need to change any time zones at this point. So again, data, text to columns, delimited, and seems that it doesn't get it like this. So let's try if we don't have the space in there. Yeah, okay, that's good. So we can go ahead and delete this one, geothermal hydro pump. We don't have that. Marine solar, we're not going to take into account solar as such a small amount, and waste as well. Wind offshore. Let's go ahead and delete these ones. And the order in here in the incomplete file: nuclear, hydro, biomass, wind, peat, coal, gas, oil. And this SE3 means the line capacity. So let's take nuclear is going to be our first. Then it was hydro, runout river, and poundage. Let's see that it actually was like that. Yeah, hydro, biomass from here. And peat, also peat. Nuclear, hydro, biomass, wind. Yeah, is the wind in there? Wind onshore. We don't actually have to state this one in here, but let's just keep it there as this kind of a average value. So then coal, so fossil, coal, gas, and oil. So oil is the last, and fossil, gas in here. So those are our capacities. And this SE line is going to be somewhat 1,300. Let's put it in there. So then comes the tricky part where you have to estimate the fuel prices. I'm just going to give approximate values in here. So this is the principle in which you would calculate these. So you want to give nuclear, for example, the fuel price euros per megawatt hours. Hydro is going to be really close to zero, so 0.01. And biomass, maybe we're going to give it 6. Wind is going to be 0.1. So I'm giving these ones values so it can, the Excel file can use these in the merit order construction. So peat is going to be maybe 8 in this case. Coal, let's put 12. Gas, let's put somewhere around 30, and oil 35. So these are really just more or less arbitrary values. And the efficiency of these plants may be 0.4. That's going to be 1. With CHP production, it's a bit lower, so 0.35. Wind is going to be 1. Maybe for peat, this is from CHP production as well. Basically, Meriporis power plant efficiency could be given in here. Coal is also part of actually the CHP plant or fleet at that time, but let's use the 0.4. Gas 0.35, oil 0.35. And then we are going to give the CO2 prices. If you're going to look this up from the internet in 2021, it ranged from maybe 25 to even 75 at that year. So it rose quite a bit. So you could take that into consideration by allocating an hourly value of that, or at least a daily value, but let's not bother in this case. we're trying to keep it simple. Nuclear intensity. So this is going to be 0, this is going to be 0, 0, 0, and for peat is going to be 1. So 1 tons of CO2 per megawatt hour. Gas, coal is going to be 1 as well. Gas, I think it was 0.5, and this is going to be 0.8. But these are, again, something you can change. So the price of production is going to be price divided with efficiency plus CO2 price times the intensity. So there you have the prices for the merit order. So what's going to change is going to be the SE3 line. So in essence, this is going to be a power plant with 1,300 megawatts, but we can allocate the price hourly on an hourly basis. So let's go to Ensoe again, and from this generation, actual generation per production type. That's what we're after. So we're going to use this one to determine the capacity factors of hydropower and wind power. This isn't exactly the best way to do it, but this is just a simplified example. So, for example, you can get the capacity factors from pages like Renewable Ninja, but that didn't offer data until it offered data only till the year 2019 at the moment. So again, universal time coordinated, and let's go ahead and change the date from here and see if the values change. Yeah, and we're going to go ahead and export the data. So UTC 2021, Finland, and actual generation per production type. And again, we are going to have to arrange them in an order that's predefined in the Excel file there. This is going to take a while since there's a lot of data, but let's be patient. So there's the download. So actual generation per production type. And there's a whole lot of data, so it looks like gibberish, but let's just delimit it like, I'm going to put the space maybe in here. Yeah, that's good. So we can go ahead and delete these ones. So what we need is and let's take off or out rather the ones that we don't need. So these ones with this NE value, they're not of relevance. So this was other, yeah, marine power and other renewable. And just going to check this isn't anything of value. Other actual aggregated. So let's take these ones out. And wind offshore and waste, that's something we don't need. And solar as well. That wasn't in such high role in Finnish energy system at that year. So at first we're going to take nuclear. So let's just go ahead and select from here the entire column. And then comes the hydro, run-of-river, and pondage. And then other renewables, we don't need that, but we need the biomass. And was it so that the next one was supposed to be wind? Let's see, nuclear, hydro, biomass, wind. Wind onshore in here. And then we have fossil peat was next. Fossil gas was the final one. Or was it so? Peat, coal, gas, and oil. Okay, so oil is going to be here. And now we can delete these ones. And I'm guessing peat, coal, gas, oil. Okay. And as you can see, 8,760 since it starts from the second row. So we can go ahead and paste those values into here. So then an approximation of this hydro capacity factor. I would say that to make a bit more accurate model, you would have to divide this hydro capacity for this run-of-river and this poundage. So something you cannot adjust and something you can adjust. So the plants you cannot adjust, so they are all the time pretty much on, is some 1/3 of this capacity. But let's not make a differentiation on that one. So instead, we're going to calculate the hydro that's being produced at that point and divide it with the entire capacity. So in essence, this is a rather poor way to determine the capacity factor. By the way, I'm going to paste the values here. So now it's just pure values and not anything that you have to calculate in the cells. So if we upscale or downscale these ones, it doesn't affect the capacity factor. And wind, so wind, and then we can divide it with the wind capacity in here. So in that way. Okay, so the only one missing is the load from here. So we're going to get day ahead actual total load from Finland, 2021. 2021 UTC. Let's go ahead and change the date, see that it's, yeah, seems to be good, and download the load from here. So that is the consumption, what we're trying to match with our power plant fleet. So let's go ahead and open this one and process the data into appropriate format again. And a lot of this energy system monitoring is downloading data and trying to parse it together in a way that you can utilize it. The last column is going to be the actual load in here. Okay, so now we have all the necessary values in here, and from the folder that you downloaded from the Moodle, you can see that, see this here, you can see that there's a lot of these different values or different files rather, and I've gathered and pre-processed these for you, so you can go ahead and attach these values from the files as well, so you don't have to necessarily go to the pages to download them, but that's also a good practice, so you will be more familiar with utilizing those sites. So the first row is going to be the kind of model or the example that you can use. So in here, what I have done is I have just gathered the price data. So in here, I can say nuclear price, that's going to remain constant. And as you know, this in some cases it's a poor assumption, but for the sake of simplicity, let's go ahead and use these constant prices. So I'm going to assign constant prices for these. There's also the possibility of using the transpose. But if some prices were to change in the future in a way that I would like to take that into account, then the prices are going to be rolling along with the calculation. So that's why I'm assigning these with individual values. So this wind production, again, is going to be this one here. Peat is going to be this one here. And notice that I'm putting the dollar signs all the time into these ones. So gas is here and oil is here. Dollars to all except for this one. So this one is going to be the SE line price. So then we have the capacities of these plants. So these are the prices. So they are in this drawing that I did in here. They are these ones. Now we're just listing them in one row, doing everything in one row, so you can jump to the next tower and to the next tower and so forth. So the next thing what we have to do is assign the capacities. So capacity is going to be this. Hydro. Now we have the capacity factor. So let's take hydro capacity factor from here and multiply it with this. So now if I upscale or downscale this hydro fleet, then it shows in the results nicely. And biomass is going to be this one. Wind. Now we have the wind capacity. And from here, you can see that in the example, what I've done is I've taken this wind capacity factor and I multiplied it with this one. You could, or actually you should multiply it with this one. But since I wanted to also see in an easy way how the changing of the wind fleet or the wind capacity would change the outcome, then I multiplied with this one. So it's easier to upscale and downscale this one value in here. But otherwise, you should let it roll along since you have the data, wind capacity data in here. But let's simplify again a bit. Peat and coal is going to be here. Gas is going to be here. Did I dollar it? No, I didn't. And oil is going to be in here. And then this SE line is going to be this one. So those are values that we can easily change. So then we need to form the price order. And as you can see in the example here, for the first hour, I have used the small function. So I placed the number of these plants. So we have 9 plants. So that's why I have 9 plants here, or actually plant types, not plants exactly. So we're going to say that small, and what array are we going to be using is these ones. So those are the prices plus this one. So we're going to have to dollar or log rather these ones with the dollars and let this one roll along. But if I'm going to multiply it to the side, then it's going to start following. So let's lock this column from here. And this is going to be price order 1. And again, if I or use the drag style option in here to see the next hour, then this would follow along. So that's why I need to now lock the number. So it's this one. So let's see if it works. Did I got it right? So this one. Yeah. So now it finds the price order from there. And we can actually check it in a way that we are going to place this one, for example, to 2. Yeah, so it's going to find it to be the third smallest price. Okay, so now we have the price order. Then it becomes a bit more tricky. Based on the price order, we now have to do the capacity order. So what we did in here, we stacked all of these values based on their price order. So this one was 10, this one was 15, and this one was 20. And hydro, in this case, would be here with the price of 25. So how do you do that in Excel? As you can see in here, I'm using this XLOOKUP function. So I'm trying to find the first price. I'm trying to find it from here, and I'm trying to give the corresponding capacity from here. So let's see. XLOOKUP, what we're trying to find is we're trying to find, since it's the first capacity, we're trying to find the first price. And again, this has to go downwards and this way, so we don't need to lock it. So we're looking at it from this price list. And this one can't move to the side, so that's why we're going to lock the columns, but not the numbers. And what you're going to return is the capacity of that plant. So based on the price order, we are determining the capacity order of these ones. So that's how the XLOOKUP works. So you can see there's a difference in the hydro and wind capacities, since we have different capacity factors, but the other ones remain constant. So then it's going to be the same thing for the tags. So in here, I have used XLOOKUP again. I'm finding this one, but now I'm finding it from finding it from the price list, and now I'm returning the tag from the list. So let's go ahead and do that. XLOOKUP, we are trying to find the first price. Again, this is the price order. We're trying to find based on that first price. We're trying to find it from this list. If something changes, and again, we're using dollars to lock down the columns, but not the rows. And then we are trying to find it from, or rather, we are returning the tag from this list. And this is something that stays constant all the time. So now, if I drag it to the side, we can see that there is this list of these plants based on the price order. So it's pretty much the same as the capacity, but now it's just the name tags. So then cumulative capacity. We have individual plants in here, or individual plant types in here rather. So what we want to do is we want to make cumulative capacity stack. So we're stacking them on top of each other. So first, if this one is activated, you have this much power capacity available, and then you're going to add to the previous one the next one. And now if we drag it in here, you'll see that the capacity rises in a cumulative manner. So if I were to draw this, it's going to rise like this. So we are pretty far in this. So what we want to find now from the stack, we want to find how much capacity do we need to activate. So this one is partially activated, but this one is, and this one is activated entirely. So let's go ahead and use this match function from here. So we can match this load value with this cumulative capacity. So let's use the match function. So the lookup value is going to be the load. In here, we don't need to log it since this is done only once. We don't need to multiply this formula to any direction. And lookup array is going to be this one. And the match type, I put one in here. So it's going to be, as you can see, it's going to be the sixth index. So sixth is going to correspond in this figure that now we have these two plant types that are entirely activated. So six asset types are entirely activated. And the next one, since our load is going to be 9,042, then what I do in here in this index part, I'm trying to find the capacity of the next plant type. So this in here, or rather, I'm trying in here to find the cumulative capacity up till this point. So you can see this index function finds this. So you can see from here, array, what is the row number and what is the column number. So let's put it in here. So index array, we are trying to find from here what we are trying to find. We have the sixth index in there, or rather row number is going to be one since there's only one row. And the index number, it's under here. So I'm going to click it to here and drag it downwards like this one. So now it's going to find the cumulative capacity up to this point. But since we have more load, the additional capacity needed to be activated is going to be load minus this one. So that corresponds to this tiny bit in here, or rather, not that one, but this value in here in this picture. Okay, so the actual capacity that we can allocate to it. and you can see there's this kind of an if statement. So what I'm trying to see in here is if this one is smaller than the match number, it means that it's fully activated. If not, then we're going to have to select this value. So let's try and do this. So if our index in here, and this can only move sideways, it can't move downwards, so I'm going to lock the numbers. If this one is going to be smaller or equal than this match number, and that can move downwards, but not sideways. Then what happens? We are going to have to see from here the thought I had in there. It's going to give us this capacity order. Yeah, from the capacity order, we're going to have to check if the plant is active. The index is going to be smaller than that 6 in this point, and then we're going to find the capacity order, the corresponding capacity. Okay. So as you can see in here, if you're going to do this in Excel, it's going to be a bit of a hassle. So I wouldn't recommend doing this Excel. At this point, you have to realize that you're going to have to move to, for example, Python, or then you're going to have to move to these designated programs such as this pilot. But in here, you can still kind of see what's going on in Excel. So this, in essence, is pretty much what you can use to understand the model better. But when you have done this and understood it, then it's better to use the designated programs. So again, then we have the possibility. So this is the condition. What happens if it doesn't, or rather what happens if it meets the condition, and what happens if it doesn't. We still have to see if this one equals, and again, I'm going to have to dollar this one from the number. Yeah. If this one equals this match, this has to be dollar from the column, or rather match +1. So it's the next value. Then you're going to return the difference. So this amount from here, and that's going to be again, the columns are going to be dollared, and if not, then 0. So let's see if we got it right. And when we drag it here, you can see these are allocated with their full capacity. This one only partially, and these ones none. So now we're nearly at the end. So then in here, what I have done is I've just looked the tag from that based on the capacity. So if I have in here the XLOOKUP function, so let's go ahead and use that. We're trying to look up, this value, and we're trying to look it from the capacity order from here. So we are basically finding their tags so it can move downwards but not sideways. So downwards but not sideways. And then you have the array from which you are selecting tag. So this is, let's see if I got the idea right. Like that. Oh yeah, no, I did it kind of the wrong way around. Yeah, so what we are searching is actually the tag. Where we are searching it from is going to be from here, and then you have the capacity order in here. So let's see if that is any better. Yeah. So remember, you learn better from your mistakes. But now it seems that I've made some other kind of mistake since this isn't what it should be. So it's finding these gases. Oh yeah, of course, from the actual capacity. Yeah, so not capacity order, since in here everything is activated. So I have to search it from this actual capacity, or return it rather from the actual capacity. So we're searching for this tag from here, and these are arranged based on the price order, and then we are returning the value from here. So why are we doing that is that we can get these into the same order as in the beginning. So the same stack order as in here. And the final thing to see is the price. So we're going to see this index plus 1 and find it from this price order. So let's do that. We have to define with index function first the array. So it's going to be the price order in here. And then you have sixth one is activated fully. And the next one is determining what is going to be the price. So if everything was done correctly in here, we can multiply this formula down to, I wanted 1 week only in here. So let's see. Yeah. So we're going to go to 169 and delete these values. So, okay, and something's not right in here. Let's see. Now the search begins if we can find something that I didn't, for example, lock down. Yeah, this one seems to be running wild, so this one has to be dollared in here. Make sure that you are careful with those ones. And something in here seems to be, oh yeah, these tags have to remain on the row like this, and then I can modify it to there. And now, then we select these ones. And after all this trouble, we're going to see a nice stack of these. So let's select this one, all charts, area, and the stacked chart. And as you can see now, we have a really nice stack chart of this production elements or assets rather. And we can change it to this quick layout where you have them on the right. So this is weekly production value. So I'm going to go ahead and delete this one and this one, and maybe a bit larger with that one and black in here. And of course, as always, remove the border. So no line in here. And now we want to draw the price curves as well. So if I draw, actually, I only want it to be till 1 week. So I'm going to select this one. It's easier to see with 1 week. So 168 hours in a week. So let's insert the scatter, and now I can move these lines. So the other one is going to be the finish, and the other one is going to be, so the actual finish price, and this one is the realized model, or rather the model price. And as you can see, it's not matching, but let's not be anxious about it yet. So quick layout, a little bit more font size, so black font and a little bit more font size, and here, and I'm just going to delete this one since I know the blue one is going to be the price curve that we modeled, and this one is going to be the actual price curve. So now, if you were to go to FinGrid, you would see that actually there's a lot more biomass. So I'm not sure if the beet is allocated to it and they have some similar prices, but I saw there was at least 3,200 megawatts of biomass at that point. And now you can see one of the prices actually starts matching the one in here. So what we have to do is we just have to modify the production asset prices. And for example, if we have CHP plants, I don't actually recall now how the CO2 price goes in there, but let's put it essentially to zero. So you can see, well, in here it's even below then. And what else? This SE line capacity, it's not the only import line. So we can put 2,500 and assume that the northern transfer line has the same price essentially. So we are getting pretty close to the actual price in here. So with this small modifications, you can see that the price is getting better and better, closely resembling the Swedish price, since that's the one that's determining our price in here. And if we were to add nuclear capacity, let's put only 1,000 more megawatts in here, and you can see the price decreases. Even though I increase the wind amount, maybe to 5,000, or let's put it to even 7,000 that it's now, the capacity factor for wind, it wasn't a windy day or windy week rather at that point, then it doesn't change too much the curve. But there you have essentially made an Excel model of the Finnish energy system, and now you can play around it in a way that you can change these prices, you can change the efficiencies, you can change the capacities, and see how the price reacts and how does this one react. The one that we took kind of from the actual data was this water power production. So I would divide it into this kind of power that you can regulate, and the 2/3 that you can use for regulation. And in here you can see pretty much 1/3 is all the time on. Well, in this case it's half and half, but basically in Finland 1/3 is something that you cannot regulate too easily. So that's the first task to do. So we actually did up till number 4. And the next one is going to be on district heating system. So what you have in the folder that you downloaded, you have district heat initial data consumption and district heating initial data production values. So here is the assets. So in district heating system, we have 2 BFB or CFB boilers, then we have pellet plants, then we have oil plants, and 1 electric boiler. And the prices are going to be here, and this is going to change on an hourly basis. I put this minimum power in here. If somebody wants to incorporate this one also into the code, so these plants cannot go below their minimum capacity because it's really hard to operate, for example, a CFB boiler under a certain load. So we can read these ones into our code. So we're going to be using Python in here. So use the files, or rather, let's watch the other file as well. So data consumption. In here, what you have is you have the consumption data, hourly basis, 8,760 elements. And if I draw it, you can see that there's going to be over 700 megawatts of this power in here. And actually, I dimension the production assets in a way that they match this one. So at each point, we are going to have enough capacity. And this is the electricity price from 2023. So let's start building the model, and you can make that in ChatGPT. what I had as a prompt was something like this. So I stated that I have the Excel files, gave it their names, numeric values start in both files from the second row. So I kind of defined that how are the uh, files assembled. First row contains tags and so forth. The consumption data has district heating consumption during 1 year with every hour. So I determined that it's an hourly resolution. Second column contains the electricity price. Initial data production values file has the first column, the names of the production plants. The second column is the maximum capacity. And third contains the price in units. And then I said the final production plant is electric boiler and its production price has to be read from the other file each hour separately. So this is the really important prompt in here. So I want a Python code that arranges the product during each hour in ascending order based on production costs and stacks the production in a way that the consumption is met. So the only production plant that moves in the production order or merit order is the electric boiler. Draw the production of each plant in a stacked area chart for the year and draw the consumption on top of it in a black line with the line width of this. And then I gave this smaller Excel entirely into the prompt so it sees better that there is asset, Pmax, and cost in here. And it can read the tags and the price values better. So what I got out of there was some more prompting to be done. So I got some errors in there, and I just gave the errors back to ChatGPT, and then it corrected the code. So it was surprisingly easy to get this one done, especially without the minimum capacities of the production assets. If you try to incorporate minimum capacities, then it's going to be a whole lot harder. But I have also a third file in there. So it's going to be this test, initial data consumption test. So what you have in here, I've already drawn it in here. So what you have in here essentially is going to be just a straight line. So the consumption increases linearly from 0 hour to the end of the year. And this is going to be the total maximum capacity of those plants, or at least near it. So, and I set this electricity price to 300, so it's all the time going to be putting this electric boiler last. So let's see how that looks. So it was test in here, data consumption test, and I'm going to run the code. So it looks like this. When the consumption starts going upwards, you activate the first asset, then the second asset, third one, and so forth. So up till here, this is pretty much the maximum capacity, or at least close to it. And it looks to be arranged in a nice order. So let's try and run the code with the actual production values. So you can see here that if we zoom in on there, you see that the first production asset is here on the bottom, since it's the cheapest. Then you have the other wood boiler, pellet boilers, and then when it starts getting colder and you need more production, then you start activating these other assets. And in here, electric boiler is slightly lower than the second oil boiler price, so that's why it's activated first. And during the summer, when electricity is cheap, then you are most likely going to be activating a lot of the electric boiler. And this is probably the cheapest option in here, but you still need more power than one electric boiler can provide in this case. I think it was only 20 megawatts that I assigned for its power. That's an unusual power for this kind of an electric boiler. This Norwegian company, Parat, makes them, and they range from 40 to 60 megawatts. So that would be a more appropriate power range in here. But yeah, this is also going to be on the files later on, so you can utilize this exact model, but try and make your own by prompting. So these were the assignments in here. So the idea was to generate a Python code to calculate the production of each production plant and draw a stacked area graph of it. So essentially the same what we did in here.